Hello, welcome to the video for 8.4 differentiating vectors. So in the previous video we looked at where we were given equations for acceleration or velocity or displacement. We had to integrate or differentiate them to find different equations. Okay, so this time we're given equations in vector form. We can basically do the same thing. So this one just concentrates on differentiation. Okay, basically what we're going to do is going to break it up into its different components and differentiate them separately. So let's crack on with an example. So here we're given r. So r is the displacement in vector form. So obviously it's written in the I and j components there. I'm going to write it as a vector, a column vector. So 2t cubed for the I, and 50t to the negative a half, and that is meters. Okay, so part A wants the speed. Speed is obviously related to velocity, so velocity is equal to the differential of r with respect to t. Now that there's a nice little bit of shorthand which I've written up here. We can just write that as r with a little thing above it. So I'm just going to differentiate this here, so doing them separately. So 3 times 2 is 6t, reduce it by 1, minus half times 50, negative 25t to the negative 3 over 2, and that is in meters per second. Okay, so that's our vector in terms of velocity. It's now told as t is equal to 4. So we can work out the velocity. 4 squared is 16. 6 times that is 96. Let's do the other one on the calculator. So it is negative 25 multiplied by 4 to the power of negative 1.5. So it gives you negative 3.125. Okay, so that's part A. So that's the velocity. It wants the speed, so we need to learn the magnitude of that. So it's going 96 to the right, 3.125 down. And this is what we want to find. So the speed is equal to the square root of 96 squared. Gives us a value of 3 significant figures. Okay, right, part B. Part B is to do with acceleration. So acceleration is equal to the differential of velocity. So the differential of this one here, 12t, times this by 1.5, negative 1.5, 37.5, t, negative 5 over 2. And it wants to know when t is equal to 2. 24. 6.629 meters per second squared. Okay, I've just left that in, put dot 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 there because we're going to use that in part C. So part C, let's shift this up a little bit. Part C wants to know the force when t equals 2. Force is equal to mass times acceleration. We know that when t equals 2, this is the acceleration, the mass is 0.8. So 0.8 times by 24. I'm going to do that second actually, just because it's easier just to times this number by 0.8 first. So the bottom number is 5.30, 3 significant figures, 19.2. And force is in newtons. Answer the question, yes we have.